Thanks everybody for coming to our webinar tonight about mini split heat pumps for existing homes. And here is I apologize. I did this last time too. I'm trying to go to the right screen. There we go. And here is our list for all of our upcoming webinars. We just finished in May, one for new single family homes, but don't worry, we have more information July 26th and August 16th about new construction. The first one on July 26th is really for homeowners and realtors, where the one on August 16th is really going to be geared towards builders, architects, and developers. But after this mini split one, on July 12th, we have one for existing homes that have a ducted system currently, so we can talk about how heat pumps can replace your current system in a home that has ducts, heat ducts. I want to thank all of our sponsors for helping put this webinar together and making sure it happened. Holy Cross Energy, Walking Mountains Science Center, Energy Smart Colorado, the Beneficial Electrification League of Colorado, High Country Conservation Center, or HC3, CORE, the Community Office for Resource Efficiency, Garfield Clean Energy, and CLEAR. Without all of our regional partners, things like this would not be possible, and we really value the partnership we all have together in efforts like these. I want to share with you this website, loveelectric.org. It really is a resource for everything heat pumps and everything to electrify your home. Has all the Colorado rebates located on this website, so not just for our area, but for all around Colorado. It outlines all the benefits of switching from gas, propane, or electric resistance to an efficient electric equipment for heating and cooling and water heating and induction stoves and things like that. It also provides explanations of cost estimates for best heat pump applications, and you can find lists of qualified installers of heat pumps on their website. Just for 1 second to mention Holy Cross Energy, they are a large utility provider. They provide electricity here in our Rocky Mountain region. We also value their partnership, and we value their incentives they provide to our region and to our homeowners and businesses. So you can see up there they have residential rebates available up to $5,000 a year. If you have new construction or new home, that's $15,000 per year. If you're building a new home. So consider heat pumps and consider that there's incentives out here, and this is kind of the requirements on the bottom that are required to qualify for those heat pump rebates from Holy Cross and from their partners. Energy Smart Colorado, one of our sponsors on this webinar. So everybody understands the Energy Smart Colorado program is available in all of these areas you see on this page. They are all throughout Colorado. And there are rebates available in all of these areas for existing buildings. So if you live in one of these areas, check out that local nonprofit that hosts this Energy Smart Colorado program. The heat pump rebates we have up in our mountain region up here for our sponsors that are the sponsors on this webinar, Summit County, Eagle County, Garfield County, Roaring Fork Valley area, Pitkin County. Here are the rebates that are available. So just as an example, Summit County High Country Conservation Center, if you earn up to 160% area median income, $4,000 is available for a heat pump rebate. Here from Walking Mountains, we have up to $5,000 available. If you earn 150% area median income or less. CORE has up to $7,500 available, and the Re-Energize program in Garfield, the Garfield Clean Energy, is up to $4,000. And that's above and beyond your utility rebates. There's some tax credits out there for heat pumps we want everybody to be aware of. There's some great links on this page. I'm not going to go through the details of these tax credits, but know that if you're going to get a heat pump in your home, there's tax credits out there. The federal income tax credits, those are for existing homes. So if you're upgrading, kind of like what we're going to talk about on this webinar today, there are tax credits out there for you. So check those out. The Colorado income tax credit is actually for both new and existing homes. So don't forget about the availability of that as well. Now I'm going to introduce our instructor for today and let him take over for us and get started. David Petroy. He has over 15 years experience in a range of renewables, energy, sustainability, and business roles. He's the founder, president of Blue Valley Energy, a successful ground source heat pump engineering, design, and installation company in Boulder. with over 200 installations throughout Colorado. During the early 2000s, he led technical sales of solar and energy power systems for residential and small commercial buildings. Most recently, he was a sustainability manager for Golden Aluminum, one of the largest single-site industrial power users in Colorado. There, he was responsible for leading adoption and implementation of a facility-wide energy monitoring system and upgrades to reduce energy consumption on large industrial production processes. In 2017, he launched NTS Energy, a consulting company focused on providing advancing HVAC and solar solutions for homeowners and small commercial industrial companies, and promoting the transition to new energy economy in Colorado. David holds an MS in geophysics from Washington University in St. Louis and a BS in zoology from SUNY Oswego. Dave, I'll let you take it away and let you share your screen.
All right, thanks, Nikki. Welcome, everyone. Got a lot to cover. I'll try to get through it a little bit quicker here, and we'll have questions at the end. So let me share my screen here real quickly, and let's get going. And I will also undo my video. So welcome. This is some of the topics we're going to talk about quickly. I'll just, how does a heat pump work? I'm going to slide through that one fast. We'll talk about how heat pumps have advanced, and that's why we're where we are today.
Dave, I'm going to interrupt you because I don't think you've shared your screen.
Oh.
Sorry.
I have not, but now I have. Okay.
Thank you.
Sorry about that. And we're going to, this is a focus on mini split for existing homes. So there's a lot of strategies, and depending on what kind of home you have or whether you're doing an addition, we'll look at the cost savings, and then we'll talk, how do you actually know you're getting a good heat pump system? What are the kind of things you do to ensure you have a good heat pump system? So I'll advance to the next slide. So a heat pump, for those of you who don't know, I think by now it's been publicized enough over the last couple of years. It's basically a reversible air conditioner. And I used to walk through this, but in consideration of time, I'm not going to. But basically, think of it this way: it moves heat and not temperature. So really, when you say, "Oh, it's -10," how does it heat my house to 70? Think of it as concentrating heat in a refrigerant and pushing heat into the house. So think of it as a heat concentrator. There's lots of heat in really cold air. We just don't necessarily, it's, relative to the warm air. So what's happened over the last decade? Why are we here now? 15 years ago, I couldn't be selling these or saying they're good things to do. Well, about the early part of the century, I call it the birth of cold climate heat pumps. Really, they were working on them in Japan and Europe for a little bit before that, but in the US, a lot of it was driven by heating oil prices, and a lot of folks were in the research labs and stuff and realized what was happening around the world. And they basically said, well, why can't we do this here? It makes sense. So there was a lot of efforts, a bunch of research, a bunch of improvements. And then from about 2012 and on, there was lots of installations. I mean, there's tens of thousands of installations in cold climates, New England, Midwest, Canada. What makes us a little bit unique, especially in the high country, is the elevation. It makes that a little bit more challenging. And so what have they done? I'm not going to necessarily, for those who are, sort of engineering geeks, this is just some of what happened. Every component was improved, and the big thing was the compressors. That's what uses the energy. So all these improvements resulted in a lot of good stuff. This chart shows the bottom line is outdoor temperature. So 0 is on the bottom left, up to 70 on the bottom right. And on the vertical axis is how much energy it takes to heat your home in MBTUs. And so this green line is how much it would take to heat a sort of a typical home. And notice, yeah, obviously it gets colder, it takes a lot more energy. Well, in the past, before this big evolution of cold climate heat pumps, this thin blue line is what heat pumps could output. So they worked fine down to about freezing, but then all of a sudden, wow, they were way short. Well, what's happened over time, all this improvement, this orange line, and even it's coming across here, is where the heat pumps are now. So you have right around 10 degrees or so. And in fact, in a lot of cases, it's even better. We've got heat pumps that can match the capacity of the house all the way down into the negatives. So number one, now they have the ability to heat between 32 and down near zero and slightly below. Oh, sorry, wrong direction. So that was number one. Number two is they've gotten so much more efficient. And this is kind of the last decade. An HSPF is a term, heating season performance factor. The higher the number, the better. 14 is twice as good as 7. 12 is twice as good as 6. So this is over the last 10 years, the typical heat pump and how much better they've gotten. And right now we're 2018, but this is really where we're at even in today. This is kind of the highest, but we're at most production lines. We're getting something around 10, 11, and basically around 30% improvement over the last 10 years or so. That translates directly into 30% less operating costs, 30% less energy use. So let's just summarize quickly. I mentioned two things: efficiency improvements, i.e. cost improvements, ability to heat really cold, ability to have high capacities. And I didn't mention this, but defrosting. So, when there's ice, when it's around freezing, ice can form on all these units. They had to have a way to defrost, keep them operating well. And they came up with better strategies to do that. Basically, rather than push air into the house for a minute or so, they basically keep it in the heat pumps and defrost them. Today's webinar focuses on what are called mini split, and some of them are called ductless. And I'm going to mostly talk about multi-zone. You can get just one outdoor unit and one indoor unit for simple things. And everything I talk about applies to that. But we're going to talk about where you can have more flexibility and do more things. And so you can have one outdoor unit, and basically you can add up to 5 of these indoor units. So this is kind of an outdoor unit. And to give you an idea, this is the thick, or the size of lines going into the house. These are the refrigerant lines, and they actually contain the power lines too. And it's about the size of a gutter, typically. So when you're running these lines in red around the house, I mean, it's very easy to fit them into spaces. You have a lot of options, and the outdoor unit does send the power. So let's look at some of these options. This is what you're all probably familiar with, is just the wall-mounted unit, still the most common application. Great flexibility. But over the last 5-7 years, a lot more have come out. These started out in the commercial world, but they make sizes for residential. Nice flush ceiling units. This is a 4-way unit. And this is a really nice unit. Think of it, instead of having it on the wall in the room, just move it up to the ceiling out that way. There's floor, they're called, lower floor units or lower wall units. I honestly haven't seen many of these because wall space is such a premium, but they are available. And then this is a very interesting evolution. It's called a slim duct unit. It basically could fit in attics or in closets, above closets, etc. And it requires just a little bit of ducts. And I'll talk a little bit more about each of these in the next slides. So these are least expensive, and they're very good. They make very small ones for small. And I mean, when I mean small, a little bit physically smaller, but small in terms of heating capacity. And they're good for middle floors where you don't have an attic above or something below to work with. These two are very good. This is becoming extremely popular. They're alternatives to this. They're good for the second floors where you've got attic space above to work with them, or if you're finishing off your basement and you've access before you've finished it off. You want a remote thermostat with those, and they do require a little bit more extra for installation. Here, the lines come right through the back of the wall, and the condensate lines come through the back of the wall. Here, you have to do a little bit of a run up in the ceiling. So there is a little bit more involved in installation. What I like about this slim duct unit is you can put it up between, if it's in the attic, you can actually heat 2 rooms on a slim duct unit. So you can have 2 of these. This shows 2 off of 1, but you can do 2 rooms off of 1 of these units. You just can have 1 duct go into 1 room, another duct going to another room. So it's kind of a 2-for-1 deal. You do need to have these small ducts, but they're quite easy to do. So you've got all of these different units that'll fit what you want to do. So what's this webinar about? What are sort of the applications we want to discuss a little bit today? One is you're going to, so up in the high country, historically haven't had much heating, but let's say now there's more needs or more emphasis on that. So you want to add cooling to a whole second floor, or you have the south side of the main floor, which is extremely hot. So you've got areas where cooling. And then you also might be driven by reducing heating costs, and then cooling is secondary. So kind of flip it around. And this is especially true for electric baseboard homes, propane boiler heated homes with radiant. And it's also a complement to radiant heated systems with natural gas. The savings on these are quite large. Natural gas is pretty much on par, though you will get some savings. If you've got a small condo, a small home or condo, and you want to convert, we'll talk a little bit about that. And then new additions, heating and cooling, and basement finishing. So these are the kind of things you can think about as you're looking at your home. Now, one thing, a little bit of deviation, and this is, basically heat pumps have kind of obsoleted air conditioners. There's still tons of air conditioners sold, but in reality, if you're going to spend money on that, you might as well just get a heat pump of the same model. So air conditioning heat provides cooling 2 to 3 months, where heat pump provides cooling and heating. And so I want to just show you these numbers here. And this is up in Eagle, and this is the various months. And based on the average temperatures, when it's warmer out, it's much easier for a heat pump to operate. So what this is how much more efficient it is than a mid 90% furnace. So if let's start in the summer, you don't have much heating at all. When you do, it's very warm. Let's say it's in the 50s, 6 times more efficient heating. What that means is 1 energy unit in, 6 energy heat units move. So unbelievably efficient. It starts to get a little colder. September, still 5.5 times, 4.5, 3, a little over 3.5. In the cold months, obviously, it's still very efficient. 3.2, around 3, and sometimes a little bit lower. But it's only in those months where gas heating might be on par. And then so through most of the year, suddenly I'm buying for a little bit more money. It might be 1,000 or 2,000 installed, but you've got all these rebates. I've got a piece of equipment that can help me almost year round. So now you're thinking about mini splits and, okay, what do I want to do? And I've talked about these 2 options here and a combination. So if you want to save money the most and you want to reduce your footprint of energy, what you want to try to do is you want to try to find the biggest areas in the house that can be served with 1 or 2 units. So if cooling's secondary, you have a great room downstairs, a big open dining kitchen area. You want to do that. You want to take that energy and you want to use the heat pump for 9-10 months of the year to do that rooms. If you want cooling, you got to think about how many rooms are uncomfortable. Can I use a slim ducted unit for a couple of bedrooms? Do I want to use recessed ceilings units for look in the master bedroom? So that's a little different game. You want to say what rooms are most important, and I can still save some money on that. Now, when you have a small home or condo, a lot of the principles are the same. You want to go to the largest area. I'm going to show a couple diagrams or an example in the next slide. You still keep the existing heating, and all of this webinar, we're not talking about totally replacing the existing heating, be it radiant, in-floor, or whatever. We're just talking about taking most of the load off. And you double up on small rooms whenever possible. So let's just look a couple little simple examples. Well, here's a little condo, and I've got my front room, I've got my back bedrooms now. So what you want to think about is, all right, initially, how much money do I have to spend? What do I want to try to do? Oh, this part's uncomfortable. I want to save some money. So I can put a little wall unit here. But one thing I want to mention is when you buy just a single unit, outdoor and indoor, you're kind of stuck. But if you want to have flexibility to move forward in the future, you want to buy one of these multi-zone outdoor systems. You might want to buy it a little bit bigger, and then put a smaller unit in the second one. So I could decide on my number one bedroom, and now I've got this condition too. I've got this. In the future, I can do something with this bedroom or the kitchen. Also, I can easily pull air through the house. If I just put a little tiny fan in this window facing out, I can actually, when this is cooling in the summer, I can keep this room cool too. Here's just a bigger example, 2 floors, a similar thing. This unit here would actually heat this entire floor, heat and cool this entire floor. But upstairs, if I have an attic above, I can do a couple things. I can do one of these slim ducted units and do both of my bedrooms out of one unit, or I can decide to put a little wall unit in bedroom 1. In the future, I can add bedroom 2. So you just want to think about, what's your progression and what do you want in the future while you want it at the same time. Now, additions and remodels, typically, if you had a radiant, you would just lay in new tubes, but you might have to upsize the boiler. You might have to add, if you're doing electrical, you're going to add expensive electrical. Not the baseboards aren't expensive, but running them is very expensive. The nice thing about this is you got some advantages. You got a simple system. And in this case, you can think about a singular unit. If you got to think, you could say, well, I'm just going to do one unit for this room. But you could say, well, I'll do it for this room and maybe I'll do another part of the house. And I don't have to upsize my oldest system. The thing about this is you want to design it, and we'll talk about sizing in a few slides. I want to make sure that it can do this room down to pretty cold, like -10 or so, if I got no other heating. Whereas in the other parts of the house, you have a little complementary heat. I need to also mention, it's very important, and this is super important for new homes, but if you're, 2 things. If you're going to air seal and insulate your house and really make it a super tight shell, this is important. Or if you're finishing your basement, this kind of concerns me that a lot of us spend a lot more time down in our basements. And in the past, if there was a window, it was a single pane leaky, but actually basements can be like living in a bread box. So you really need air in them. And why are we doing this? I like to open my windows. My wife opens the window. We live windows open, but the times we don't is very cold, hot, or, smoke from these big fires. So what is a heat recovery ventilation system? It's like brings in fresh air in and out, but it exchanges the energy. And I'm not going to spend a lot of time on it. This is a simple diagram: cold air from the outside, the warm air from the inside, this box here, it exchanges the heat. So basically comes in warmer. If this air is 10 degrees, doesn't come in at 10 degrees, might come in at 40 or 45 degrees. And then there's ways to sort of warm it up before it gets your feet cold. There's now really small units. These things used to be very big. This is a small one that's built into your ventilation fan for your bathroom. And then these are kind of the latest and greatest. These are a little through the wall. So actually now with this little pair, and it's a very clever, I'm not going to go into it, ceramic heat exchangers. I can put these in rooms throughout my house and have fresh air coming in no matter what the outdoor conditions are. Great way to go. So I showed that monthly chart of how efficient heat pumps are. You can think of over the course of a year, they're roughly about 3 times more efficient. And that's called COP, coefficient of performance. It says, if I put 1 unit of energy into something, how many units of heat am I going to get out? So a heat pump's moving heat. It moves 3 units of heat energy. A good furnace, 95% furnace, burns gas at 95%. So it rarely uses only 33% the average energy of the other ones. So it's going to save you quite a bit of money. Now, what I just want to show, one of the misconceptions in Colorado and all over, and it's just counterintuitive. This is the outdoor temperature, -20 up to 70. And then this is the percent of annual energy use. So even though when it's really cold, you use a lot more energy, it turns out the hours in our climate are not relatively not as much. So notice down to about 15 degrees, I've got almost 85% of my energy being used to heat my house. It's only it's only less than 20% when it's really cold, and even less than 0 is less than 10%. And then this is just a different way to look at it in terms of outdoor temperatures. And I showed you how well heat pumps do when it's 30, 40, 50, all these blue areas in here, February, March, April, super, super efficient. I'm not going to go through all these numbers because everyone's going to get the presentation. This is against if you're replacing baseboard or propane and what size area you do and how much savings you can get, how many years. Basically, can think of it as, somewhere between 4 and 6 years. I do all the savings. It could be sooner with increasing prices. Natural gas, you'll save right now. You save a little bit, a few percent, but you're going to get cooling and a little more comfort. So. And of great energy savings. We're talking about cost savings. Energy savings against gas is still tremendous. Sorry, next slide. So all this good stuff, how do you really know you want to get a good heat pump system? And I think it's definitely diminishing, but in the past, people say, oh, I got a heat pump that didn't really work or it cost me a lot to operate. So we're going to talk a little bit about this, and we're going to go through and just kind of step you through the idea as homeowners is to give you enough knowledge that you have the confidence to talk to contractors and understand and know that you're going to get a good system. So here's some of the things that happened in the past. First of all, 10 years ago, people were putting in heat pumps in Colorado that really wasn't a cold climate heat pump. So it would work down to 30 and then it wouldn't really work below that. They weren't sized right. They weren't designed for the right temperatures. The result was the units were undersized in terms of heating ability. And this is another one, is poorly installed systems. And so this is what happened, they don't work when it's super cold, and they were more than expected to run. Well, number one is, how do you know you're going to get a good cold climate heat pump? And all the rebates and Holy Cross and Rocky Mountains, there's criteria, and if you beat them, you're going to have a cold climate heat pump. But this is just general guidelines. When you're online, you'll see if you go to any website, they're going to say variable speed compressors. So that's really a key. That's a cold climate, operates at least, for the rebates, it's -5. So here's some examples of ductless one, mini splits. And they've got sort of their brands. Mitsubishi's called Hyperheat, Daikin's Aurora, LG is L-Grid, and Fujitsu is Allison XLTH. And these are the big established players in this one. You want to think about how you want to ask about specs and the warranty. So this is going to be kind of a crash course in systems. You can spend 3 days trying to learn this, but I try to simplify it so you understand how does a contractor, how do we figure out what size you need. So there's Manual J. It's software that is well established, and you sort of build a little model of the house or the room, and you say, where am I at? And Eagle, it says, okay, you should make sure it can design to -6. And if the mini split is a sole source for separate edition, you want to make sure it goes to extreme temperatures. And when your load is between two sizes, the contractor is going to always go for the bigger size because heat pumps are only in discrete sizes. And this is what I talked about before. If you want to add over time, you can get a higher capacity outdoor unit to indoor units. So let's go into the sizing. So heat pumps are defined by tons, same as air conditioners, for those of you familiar with air conditioners. 1 ton is 12,000 BTUs per hour. And so these are the sizes of outdoor units. Basically, for these mini splits, most of them are between 2 and 4 tons. And it's in the model numbers, and this is kind of how many rooms you could do. Now, in the indoor, in each of with these mini split wall units and other units, you size the indoor unit also. And it's very similar. They're much smaller though, 1/2 ton, 1, you know, and this is the size, and this is kind of the rooms that you can do with them. Now, with duct systems, people did this by designing sizing of the ducts and how much air went into each room. But now we're looking at actually the component. So let me go back and summarize this. So the contractor is going to size it with this software. And sometimes it's between these sizes, and they're going to go with a little bit bigger size. If you want to think about starting small, but you have to say, well, I'm going to start small. I'm only going to do 2 rooms, but I might add more in the future. So I could go to a bigger outdoor unit, gives me a little more capacity. So that's sort of the very simplified version. So contractors, and this is a big time of transition for the industry. Contractors are extremely busy. It's kind of the heyday for HVAC, quite honestly, this huge transition, not only to heat pumps, but just energy transition in general. So obviously talk to friends. You can go on the manufacturer sites and they have all kind of certifications. I think a couple things, you can go on their websites. Do they talk about mini split and ductless? Is it up front? They talk about, hey, heat pumps and these are just some certification. Now, sort of getting to the nitty gritty is, you know, you don't want to, first of all, people are very busy. It's hard to get them out, but you know, my recommendations is just to get a couple quotes to start. And you want to be consistent. You want to get these things to be consistent because there is a lot of mix and match, but contractor 1 might come out and you say, I want a couple wall units in these rooms. And they'll say, this is the size. And then contractor 2 come out and might say, okay, yeah, but maybe I have a little different size. But you want to go back and forth and say, okay, I want you to be consistent. So that's number 1. If they're far apart, you want to get more quotes. I'd be very cautious of low quotes these days. And it's really not fair to go online and compare things. I mean, it's unreasonable to expect because online is, as I think everybody knows at this point, is rather distorted. I'm not going to spend a lot of time on this because kind of running a little bit long, but basically there is a lot of online brands that haven't been around a lot. I would just say this, and here's where if the distributor in the state carries the product, and you've got contractors that can put the product in, you know, if anything ever goes wrong, you're going to be able to fix it, be it 3 years, 5 years, 7 years, 8 years, 10 years, 12 years. I can't really comment on all these newer brands and the reliability. There's not enough statistics. I do know one thing, that if they don't have presence in the state or around, they don't normally have replacement parts, etc. And so if you want to go that route, the chances are you might not be able to get it fixed. So outdoor units. Well, there's a few things you want to think about. So noise, these are getting quieter and quieter, but think of a quieter AC unit. AC units, you're just going to use in 3 months of the year. These you're going to use about 9 months. Well, it typically doesn't matter when it's really cold because you're not sitting outside. It doesn't matter when it's super hot. But it's kind of like May and September, 40, 50, sunny. You want to sit out on your deck. So one thing is to try to think about that when you put them. I'm not saying they're terrible, but it's something you want to try to think about. You don't want to put them right under your bedroom and go either. Now, you want to try to keep, if possible, put them in sort of the south side. It helps defrost. Sun is, everybody loves sun, even metal equipment. Wind does have a little tiny effect on the performance. You want to keep them sheltered. And a couple notes about snow shelters. This is the typical geometry of a mini split ductless. The air blows through in a horizontal fashion. But some, not a lot. This is more of a ducted system, but here the air comes in and goes out vertically. If you're putting a shelter on this, it doesn't have to be as far off. But these, and you'll read online if you ever start reading about putting covers on heat pumps, you have to have a couple feet above. So you have to sort of build a little mini roof on this, because if it's too close, it'll block the flow. You also want to make sure that it's high enough. I don't want to shovel it out. And then you got to have a heater for the drain pan, and you don't want this, it can get iced over and it's going to flow out on sidewalks. You want to ask for pictures. This is nice. Look at this, high off the ground, covered up, etc. So indoor is really interesting. A few things, those lines that I talked about that run from the outside unit to the inside unit, you want to try to keep them to a minimum. They're designed to go pretty long runs, but so it's a little bit of a puzzle. Like I want to find a good spot for the outdoor unit. I want to put the indoor units where I want them. So sometimes you're a little bit limited, but if you can, you have a little bit of play there. Condensate lines. This is really important. There is a little bit of condensate that comes out of the indoor units. Not an issue. Usually they're piped, but this is the area that the installers will spend a little bit of time. They got to insulate them. You as a homeowner will want to actually once a year or have this stuff maintained. They'll come out and they'll sort of suck the condensate lines, make sure they're not clogging up. This is the area you want to talk to the contractor and just pay attention to. These recessed units, you're going to want to insulate them, and they have to be able to be serviced. And this is something I noticed in a lot of the installation guides. There's you want to keep them away from electronics. 3 feet's not very far. So let's summarize. These units, evolution is great. Now they work well in Colorado. We've got new tools. We've got a lot of options. They're going to save you some money. Think a little bit about what you really want to do. And then talk to contractors, get some good advice. And there's a lot of local contacts Nikki has when she sends out the deck. Tons of folks here that can help you out. I think she's, there's a lot of help. There's Love Electric, etc. So feel free to contact any of these folks, and they'll help you out. And that's all. Thank you.
Thanks, Dave. Thank you, everybody, for being here and making it. Again, I apologize for the problems with the link at the beginning. There are a couple questions, Dave, so I'm going to read those to you and have you give us your best answer. The first one is, I currently have a boiler heating baseboard heat on the upper level, which is over a garage. The garage is heated by the same boiler and blows hot air through a radiator. The boiler also heats hot water for both upper and lower levels for personal use and consumption. What are your thoughts?
Um,
And it's in the
I don't know,
Q&A
it
box.
depends on what the goal is the goal to try to eliminate the boiler?
Do you want me to let him answer? Let him talk. Let
Yeah.
me
Yeah,
find this
sure,
person and
that
let him
might be
talk.
good.
Allow to talk. Okay, whoever asked that question, I've just allowed you to talk.
We've had some boiler issues in the past, and I wouldn't mind replacing the boiler. But at least have some type of backup at the very minimum.
Okay. So this
We
is
have
for the
about
garage.
800 feet up and 800 feet down that we would keep warm, that we would heat.
Okay. Well, okay, so how many rooms are we talking about, I guess?
2 rooms, 1 up and 1 down.
Oh, okay. That would be actually quite easy. You probably
yeah.
could get away. It sounds like it's a pretty small space, and when they're very small spaces, you could remove that boiler system and use the mini split. You would just make sure you could size it down so it heats to when it gets pretty like -10, -13, and there's
the water supply, it comes from a well and it comes in downstairs in the garage area, so that has to stay well above freezing.
Yeah, no, this will be no problem because it's a
Okay.
small building,
Okay.
2
Yeah.
rooms. So you could do that. And if you got really concerned about it, it would be very simple to just, you could basically take out oil and just put a tiny little electric heater if you ever needed it. But honestly,
Yeah, we did last winter.
Yeah, with the right design, you should be fine.
All right, thank you.
And if you want, you can contact me with specifics and we can chat a little more.
Okay. Thank you.
Sure.
Thanks, Dave. Another one, this is from Robert. I have a swamp cooler on my roof of my 1,200 square foot house that has 3 ducts to the rooms. Is there a unit that I can mount on the roof and send heat and cool air through the existing ducts?
Yeah, there are units that can do that. Packaged units, they're more for commercial, but yeah, and we can talk a little bit more. You get a better idea of that in the next webinar on the duct part. But yes, if you contact me, I can point you in the direction there.
And Robert, that next webinar we have scheduled will also give you some more information. So even if you just register for that next webinar, we'll send a recording out of it as well as this one here. So if you can't attend that next one, we'll send you a recording if you register. We have another, let's go through some more questions. Do you have recommendations of trusted contractors that serve the Roaring Fork Valley? I will say that there are contractor lists available from both CORE and CLEAR. So I would contact those nonprofits as well as Holy Cross Energy. All of those folks have contractor lists and they service the Roaring Fork Valley, so they can direct you to the right contractors that can help you with heat pumps. Do you need an electrician to wire the system? Dave?
Yeah, you should have an electrician. It's 220 volts, so you should. Normally, the electrician's going to wire from the panel to the outdoor unit. And most of the time, the contractors, like, you don't have to hire a separate electrician. That's just part of the whole install.
And then there's a question here, does Excel offer any rebates? I'm sure they do. I cannot tell you right now. I apologize what those are off the top of my head. Do you know, Dave?
$2,000, I believe it is.
Okay. So Excel's is around
For cold climate heat pump. Cold climate heat pump.
And if you contact any of these nonprofits listed on this page, any of us can help you understand the utility rebates as well and connect you to those utility rebates. Let's see. Mary also posted in the Q&A, and we'll copy this over into the chat from CORE, their list of contractors. So you can just look at this link here. It's in both the chat and the Q&A right now. So that's some contractors in the Roaring Fork Valley, back to that other question. We have an anonymous question here. The existing house has electric baseboard and Vale. I want to supplement heat with an outdoor mini split and have capacity for a planned addition. How hard is it to install the system do it yourself?
I mean, unless you're really familiar with this stuff and refrigerants and everything, you can get in a lot of hot water. But honestly, I don't know your background, so it's hard to judge. But I know people are trying to do it more because they see it online, and you can get into trouble pretty easily. But like I said, unless you've got direct HVAC experience with refrigerant, understand that, and the controls, I would advise not doing that. But if you want to chat more, send me an email.
Yeah, you can raise your hand if you want to talk. Whoever that was that asked that question, it was anonymous, or you can email Dave. Dave, do you want to pull up your page with your email address so they all have that, and give Dave some more information?
There it is, there at the bottom.
There we go. Can you give us an idea of the cost of a mini split heat pump for one big room, about 1,000 square feet?
Where do you live, Julie? In the Front Range or up in the high country?
Julie, do you want to talk, or do you want to put that in chat, or Snowmass? Julie's in Snowmass.
It's probably going to be one head, say like 15, 17,000.
And Julie, we can get you some contractors that can give you a bids on those things as well.
It's tricky. It's all over the place. But what I would do, Julia, I would have no hesitancy if I were you, just getting a couple contractors and have them come in. It's a simple thing and say, here's what I want to do. What's the price?
And so it looks like we not only have that link for those contractors in the chat, but Mary also posted, just so everybody has it, a link to a page with tax credits for more information. I want to go up to, there's a question that says, are there any rebate options in Mesa County? Does anybody on this call know of any rebate options in Mesa County? I would recommend, if you're looking for rebates other than our area of those sponsors on this webinar, to look at that loveelectric.org website. They list all the rebates in Colorado. So you can look for your utility, your nonprofit, or your area from that website and find out what the rebates are. Let's see. We have a question. Can the rebates you listed be stacked on top of each other? Can you get more than one? So the answer, simple answer is yes. I think you're referring to a rebate from your nonprofit and a rebate from your utility. Yes, you can get both of those rebates stacked on top of each other. So you can get more than one. You wouldn't be able to get a rebate from two different nonprofits, but most likely you're not going to have two different nonprofits that service the same area with rebates. So you can definitely get a rebate from that local efficiency program as well as your utility.
And you can also remember stack the tax credits. So
yes, and then on top of that, that's
$3,000, $2,000 federal and $1,000 from the state, roughly. So it's quite a nice addition.
Any other questions that anybody has? You're welcome to raise your hand and I'll allow you to talk. You can type it in the Q&A or you can type in chat. Another good information Mary put here in chat is in the Roaring Fork Valley Core is seeing quotes from all the way from 11,000 to 60,000 for a heat pump install, and definitely get more than one quote, at least two quotes. And here in Eagle County, we are seeing a wide variety of quotes as well.
I mean, I would just encourage everyone, especially, if you're on propane or gas, this electric, this saves you a ton of money. And natural gas, if you want cooling, like I showed in that one slide, don't buy an air conditioner, just get a heat pump. With all the rebates, et cetera, it'll be probably lower cost put it in, and you'll get, you have all this other advantage.
We had a question, how long do the rebates last? Rebates are usually decided for a calendar year, both from utilities and from your nonprofits. So whatever rebates we have out there right now, we're all at least intending to provide those rebates through December, as long as the funds are available. Any other, let's see. Water heater is 25 to 30% of annual heat load. Can you get a water heat pump, a water heater heat pump that works off the outdoor unit?
No, but heat pump water heaters are now becoming mainstream. All the big, you can go to Home Depot, Lowe's, get them. You can get them online. All the big manufacturers do heat pump water heaters. And they're packaged units. So the only thing you want to think about there is nice rebates. You kind of have a big enough area to do it to get the heat from. So if you want to reach out, I can help you a little bit on that one, or we can chat a bit, or you can call a couple folks. But yeah, it's a real simple, nice way to do it. You might have to run a 220 line, though. That would be the only other thing.
Connor had a question, if there was a link to the ROI projected savings. Connor, we will send out the slides if that's what you're referring to, the slide that Dave showed. I think that might be what you're referring to.
Yeah, that was the one. I had the one slide. You look at that, and if you need more details, let me know.
Yeah, we'll connect you, Connor, with Dave. What if you can't get a contractor to do the work within the time limits of the rebates? Every year, usually, I mean, I can't say what the rebates will be for next year, but traditionally we've always had rebates the next year. Sometimes they change, sometimes they're the same. So I can't tell you what the rebates are next year, but I can tell you that I'm pretty sure there'll still be some type of rebates available.
I think that's a good point. So a lot of folks are in this dilemma, like if your furnace is getting old, well, your air conditioner is getting old. This is usually not so much with this webinar, the next one. But if you're thinking about this, it's really good to go out and get a couple of quotes, so you know in advance. I wouldn't do it if you have no intention of doing it this year. But if you're thinking about, I'd like something before the winter, or I'd like something before the summer, it's good to plan ahead and do that. It's really important, and these rebates will last this year and at least through next year, for sure.
And I would just encourage you to be in touch with your local utility or local nonprofit even before you start that project, so that they can continue to communicate with you about those rebates if they change. Can you have multiple outdoor units if there is a potential for a future addition?
You can. I mean, I guess my thing would be knowing how big what you need now is, and how and what the future addition is going to be. Because if you can do it with one bigger outdoor unit now, that's much better than having to buy 2 outdoor units and maintain 2 outdoor units. So you can get, obviously some homes are so big they do have 2 outdoor units and say 3 or 4 indoor units on each. But if you can avoid that, I would encourage it. So it just depends on how much you're trying to do.
We have a few things in chat here, Dave. Do the mini split systems use 110 volt or 220 volts?
220. And remember, though, the nice thing about it is you just run a power line to the outdoor unit, and then it powers the indoor unit. So when the contractor's refrigerant line, run a couple small power lines to each indoor unit.
Another one, I live in a condo that has 4 units in the building. Do HOAs typically allow installs of outdoor units? Tough question.
Well, that's $1 million question.
Yeah.
We have some projects now. We're working with associations, HOAs. I think that they would be inclined to do it. I mean, it's obvious you have to be cognizant of where the main thing there is, where do I put the outdoor units so my neighbors and everybody's happy? And there's tricks to that. You know, you can put a little landscaping around it. You could actually put like a little landscape wall around it. Not too close to it, or try to put it in places where your neighbors won't bother them. Maybe up higher up or something. So I'm just going to say you need to start a dialogue with the HOAs and your neighbors. And I think most people, once they understand it, well, hopefully, you know, will be acceptable to nice locations.
This kind of is another outdoor placement kind of question. Do outdoor units need to be covered? And is it possible to install an outdoor unit outside on a brick house?
They do not have to be covered. The manufacturers do not have regulations that say it has to be covered. It's just good practice to cover it, like anything, just to keep the weather out of it, the snow off of it. You know, it helps it when it's a storm out and really blowing like crazy. Any little bit of, you know, it has to work a tiny bit harder. With the units that blow up, I really think, yeah, keeping this, you know, stuff from going down in it is good. Like I said, none of the manufacturers say you have to do that. These things are designed to be outdoors and weather it. It's almost kind of like the equivalent of putting your car in the garage or having the car outside, right? Your car can survive outside, but it's better for it in the garage. What was the other part of the question?
Can you put them on the outside of a brick home?
Yeah, you could mount them anywhere. It's just, you know, just make sure the contractor, just with the right mounting hardware. I should have mentioned, I think it's in the slides. You know, when you put them against the walls, often you'll want a little bit of vibration isolation pads in there. They don't have to be big, but just it helps.
And another question, how many years will a good heat pump last before it needs to be replaced?
About 15 or so.
Our 3,600 square foot home is heated by a gas boiler with in-floor radiant. Is there affordable heat pump units that would generate enough BTUs to heat this space using our current hot water radiant system?
So that's a air to water system. They are out there. There's quite a few in Canada, but there's like one person in Colorado that designs and specs them. He's fantastic. He does a great job. But since the volume's so low and the equipment isn't necessarily in the state, it's expensive to do that. But if you want to pursue it, certainly please contact me and I can connect you with Hans. He's a great individual.
And I think Hans is on all of our contractor lists too.
Yeah. So you know, that's where it is now. The thing about the mini splits is, you know, you could look at your house and say, hey, there's a couple areas you could put a couple mini splits in and turn down your radiant heating for 7-8 months of the year and just use it when it starts to get cold.
Mary from Core just posted in chat that Diamond H Enterprises in Roaring Fork Valley is also installing air to water heat pumps for in-floor heat. So they might also work with Hans on that. I'm not sure, but sounds like there's contractors starting to do it, which is great. All right, it looks like we have no more questions. Thank you, Dave, for providing all this great information for us today. And can you bring up the slide with the list of the webinars on it if you have it? If not, that's okay. There we go. So we will see you guys for our next webinar, hopefully for ducted systems. And I promise you all that I will go in and double check all the links so you get the correct link and the correct information to be able to log into the webinar next time.
Tell all your friends who have houses with ducting.
Tell them all.
Really, it works well for that too. It's a very.
And a reminder that I'll be sending out this recording for this webinar as well as the slides within the next week. And you can reach out to any of those nonprofits with any questions at all. Thanks, everybody. Have a great night.
Thank you, everyone.